Alright, problem number 2. On the playground, 3/4 of the children are not wearing their hats, and 2/5 of the children are not wearing their gloves. What is the minimum number of children wearing neither their hats nor their gloves? Alright, well, when you see these kinds of problems where you've got sets of kids that overlap, my hint to you would be to draw a Venn diagram. Okay, so we're going to draw a circle here that represents all of the kids who are not wearing their hats. Okay, so this is no hats. And let's draw another circle that represents all the kids who are not wearing gloves. So this set has no gloves. Alright? So now so we have some kids who aren't wearing a hat, and we have some kids that aren't wearing a glove. We have some kids that aren't wearing either. That would be here in this section, here, this overlapping football region. But we might have some kids out there that are wearing their hats and their gloves. So I am going to draw a box around this whole thing, and that will represent the total number of kids that are out there on the playground. Okay? And the kids will fall into one of these categories. They'll either have no hat, no gloves, no hat or gloves, or they might have both their hat and their gloves on, which in that case they'd fall outside of the two circles but inside the box. Okay? So, so that'll help us organize our information. Alright? Now the really tricky thing about this problem is that you aren't given anything about the numbers of kids. You're given information in terms of fractions of the total number of kids that are out there. Okay? So let's define a variable like k. So we'll say k is the total number of kids out there on the playground. Alright? And we know that if we take k times 3/4, okay, 3/4 of the kids are not wearing their hats. So if we take 3 times or 3/4 times k, we will get a whole number. All right, that has to be, because you can't have half a kid not wearing his hat. That'd be embarrassing. I don't know. So no place to put the hat if you have only half a kid. All right. So and then when you take k times 2/5. Alright, again, you'll get a whole number. Oops, whole number. Alright, so we have to have a k that when you multiply times 3/4 you get a whole number, and multiply by 2/5 you get a whole number. So that means that k has to have a factor of 4, and it has to have a factor of 5. Otherwise you won't get a whole number, right? So, and the smallest number that that k can be is essentially the least common multiple of 4 and 5. Alright? And you can see that 4 is just 2 times 2, and 5 is a prime number. They don't have any common factors. So the least common multiple of 4 and 5 is just 20. Alright? So, we're asked for the minimum number of kids at some point down here in the answer. So the minimum number of kids that can be out on the playground has to be 20 in order for in order to get a whole number of kids when we multiply it by 3/4 and 2/5. All right? So that's the main trick to this problem. And once we have that, it's not too bad, because we can just say, okay, we have 20 kids total out there on the playground. Now, I usually, to represent the whole set and not just a region, I usually write it on the line. So, for example, this 20 represents the whole set of all the kids that are out there that aren't wearing their, it's all the kids that are out there on the playground. And we know 3/4 of the kids are not wearing their hats. So we take 3/4 of 20. So 3/4 times 20, that gives us 15, right? So 15 kids are not wearing their hats if we have 20 total kids out there on the playground. And 2/5 of 20, that will give us the total number of kids that are not wearing their gloves, so that will just be 8. So there are 8 kids here that are not wearing their gloves. Now you can see if you add those up, you get 23, right? So that's more than the number of kids out there. So there has to be some kids out there that are neither wearing hat nor gloves. So they're in this overlapping region. Alright, so let me scroll down here. So let's figure out what that is. I guess I put an X here previously, so I'm just going to call the number of kids that aren't wearing hat or gloves, we'll call that X, and I'm going to also write a variable here, Y, which represents the kids that are wearing both their hats and their gloves. And we know that the whole thing, all the kids in all these regions has to add up to 20. So in this region we have 15 minus X, and in this region we have 8 minus X, right? If we were just looking for the number of kids that have no gloves, but they do have a hat, that would be 8 minus X. Okay, so that's just this region without the football shape, okay? Just the area in this region. And over here too, if we're looking for the number of kids that have their or have no hat but do have their gloves, we'd have to subtract out this football shape X region. Okay, so if we add up 15 minus X and 8 minus X and Y, we should get 20. So let's do that. So well, I'm just like 15 minus X plus X, that's just 15, and then plus let's see, 8 minus X, right? That'll be everything in the two circles. And then if we add Y to it, that should equal 20. All right? So we're trying to find the minimum number for X. So I guess what I'm going to do, I'm looking for X, so I'm going to move it over so it's positive. So I'm going to actually add X to both sides. And I'm going to subtract 20 from both sides. Alright, so then we'll get, oops, that looks like a 26, but it's supposed to be a 20. Alright, 20. Alright, so we have 23 minus 20, so that's 3. Minus X plus X, that's just 0. Plus Y is equal to X. Alright, so X is equal to 3 plus Y. Now we're looking for the minimum number for X, and you can see that we had to take 3 and add Y to it to get X. So in order to get the minimum, this would have to be 0, okay? Because if we have one kid that's wearing both their hat and their gloves, then we have to have one more kid that's wearing neither in order for this all to work out. Okay, does that make sense? So if Y is 0, then X has to be 3. Oops. Alright, and X represents the number of kids that are wearing neither their hat nor their gloves. Alright? So that's our answer. We had to do a couple of things to get the minimum. We had to assume the least common multiple number of kids in order, the least number to get a whole number of kids, right? So this is the least common. We had to use the least common multiple here, and then we also had to assume that there were no kids that had both hats and gloves. So, so the minimum number of kids that are wearing neither hat nor gloves is 3 kids. All right, and that's your answer.